I just read an interesting comment that somebody made to a posting on Quora, and the posting was an answer to the question, how do capacitors take 3 volts and transform that 3 volts into thousands of volts? And the person answering used the example of a voltage multiplier based on 2 rows of capacitors in series. They were 1 nanofarad each, that could withstand 20,000 volts of charge and discharge. And what linked them was a ladder of diodes, and this is often used in an ion generator to build up voltage. Well, there's no coils there, so it's strictly voltage buildup. Anyway, that was the answer, but the comment somebody made was the capacitors charge in parallel and discharge in series, which is significant because if you've got a lot of capacitors and they're all being charged at the same time simultaneously with each other at the same level of voltage that each other is discharging into the others, so maybe not at the same time. I think what happens is one rail charges from the discharge of the other rail, and they take turns, they take sides. Well, this is very similar to Eric Dollar's analog computer. The only difference is instead of diodes, we have coils. And literally, one capacitor in each module is getting charged while the other one is discharging. But both are also getting charged at the same time. That's where the parallel comes into play. So it's a 4-part cycle in which the 2 capacitors of an LMD module are charged at the same time in parallel, and then one discharges, and then they're both charged again, and then the other one discharges. And that's a presumption of mine. I don't know that yet. But if we just break it down, what happens when one capacitor discharges? At the same time that it's discharging, the coil is going to be exhibiting its back EMF. So here is a situation in which coils invert their current polarity during their back EMF stage, or when the coil collapses, the magnetic field. I don't know, one or the other. I'm still confused on that point. But they do go through a current reversal, and that will be happening at the same time that, I should have done it this way. So let's say the capacitor is over here, and the coil of wire is down here, and there's another capacitor over here. So this capacitor is discharging at the same time that this coil is experiencing back EMF on the second half of its cycle, because the first half it was sending energy up into this coil, into this capacitor. And now it's experiencing back EMFs, which is going in the same direction as the discharge of this capacitor. And that adds current to the discharge of this capacitor. So that makes the difference between Eric's LMD analog computer and a simple voltage multiplier involving diodes and capacitors, in which here in LMD module, we're getting a buildup of current along with a buildup of voltage, whereas in a ladder arrangement of diodes and capacitors, all you do is build up voltage. So the LMD module is very interesting in that it also is a voltage multiplier, but it takes current along with it and builds up the current as well. And that's what's so fascinating about the analog computer of Eric Dollard. But because it's a circle, it never ends. You know, with the voltage multiplier of diodes and capacitors, it's 2 parallel rows of capacitors with a ladder of diodes between them, and so it ends. It has a terminus and it has a beginning. It's a linear arrangement. Now, I don't know what would happen if you turned one end around and hooked it up to the first end and just injected the voltage with a snap switch. What would happen? Does it just build up voltage, continuously until the thing fries itself? But there's no current. So do you start putting coils in parallel, another rail of coils to go with the 2 rails of, or maybe 2 rails of coils to go, one each to go with the rail of capacitors? I don't know, to be hooked up in parallel. That would be analogous to the Bewley archetype, now that I think of it. That could be very interesting. Oh, I got to try that.